Hey everyone, Mike with Mike W Consulting Services here, and I wanted to bring you another video on creating a NAT translation utilizing the VYOS routers. Now, I've talked before about the VYOS routers and showed you guys why it's such a great free tool to use for your lab or even your production environments. So in this video, we're going to talk about actually setting up some NAT rules and NAT address translation. So let's get started. So before we get into configuring NAT on the actual VYOS router, let's quickly talk about what NAT is and what its importance is. And what we first need to understand is what's called IPv4. And IPv4 is the original addressing standard that came up. Now we have new ones out now. IPv6 is a big one that everyone's transitioning to just because it offers more options. Well, with IPv4, which is still everywhere, pretty much every network you're going to find is still running some form of IPv4. But what we found was we wanted every computer to have an IP address. That was the way the internet and networking worked. Well, unfortunately, we quickly found out that IPv4 was not going to help us because it had such a limited number of IP addresses. You can see that IPv4 typically works with 4 octets, 4 little points here that are called octets, and they range between 1 and 255. And typically 255 is reserved as a broadcast address, and then some others are taken out. So we had to come up with something pretty quickly before we completely exhausted all of our public IP addresses. So we came up with IP private addressing. And private addressing is what you're going to use internally for your network, and it is not routable out on the internet. So if, say, one of these computers got out of here with a private IP address, once it hits the www internet, it's not going anywhere. It's just going to drop it. So you might be asking, well, what are the private IP addresses? Well, the private IP addresses start with, you have 3 different basically subnets you can do, a Class A, a Class B, and a Class C. The Class A network is 10.0.0.0, and that goes to 10.0.0.255. That's the first one. The next one is a Class B, which is 172.16.0.0, and that goes to 172.31.255.255. The last one is probably the one you see used the most, and this is the 192.168.0.0, and that goes to 192.168.255.255. And this last one is the one that you typically see on your home routers or home networks. That's what most manufacturers like Linksys and Netgear and D-Link typically use for their private IP address spacing. Well, so how does NAT actually work in this case? Well, it's actually pretty simple the way it works. So let's switch over to something I can draw with here. And let's make sure I have a good size. Perfect. So what's going to happen is one of these computers wants to talk to my web server way over here. So what's going to happen is this computer is going to basically say, I want to talk. So it's going to go to the router. And what's going to happen is the router's going to say, oh, well, you're 192.168.1.10. I can't send that out. So I'm going to translate you to my public IP address, which is this 205.223.128.10 address. And that's what's going to be sent out to the web. And then it's going to get translated back. And that's what this server is going to see. It's going to see 205.223.128.10. And it's alternately the exact same thing for the other guys. If this guy now wants to talk, it's going to get translated to the same address. And it's going to go to the same server in this case. And then same with this guy. He's going to go and he's going to get translated to the same 205.223.128.10 address and go out. Now this is how essentially NAT address translation works. This is more like PAT. And the main difference with PAT is that NAT typically can be a 1-to-1 ratio. There's also dynamic NAT, which is not necessarily a 1-to-1 ratio, but PAT is more like what I just described. The router keeps track of which computer did which request. So it keeps track of the request that this computer did. So when the traffic comes back from this server here, the router knows which computer to send it to. As my drawings are pretty horrible. So that's how NAT and PAT essentially work. And this has actually dramatically decreased the need for additional public IP addresses, which is awesome because we were running out, essentially. We don't have enough to supply the entire internet, which is where IPv6 comes into place. Now, what we're going to talk about next is NAT from the other end. So if this server here wanted to initiate traffic to one of the internal computers, how can it do that? Well, it can't address the computer directly because that's a private IP address, and it's going to be dropped once it hits the public internet here. So how does this work? Well, what's going to happen is we have a rule set up in here, and excuse my handwriting here, but we have a rule set up on our router here that's basically going to say if something comes to port 80 on this router, I want you to forward that traffic to this .10 computer here. So we've created that rule, so if this guy now initiates traffic, goes out to the web, and then it hits our router's going to say, hey, that's coming in on port 80. I know I need to translate and send this traffic to this computer. And this is how you can have multiple computers within a private network be able to answer on certain ports within a public network. So now that that's probably as clear as mud to you, let's get into the actual VYOS configuration. So here we are on my Virtual VYOS Router now. And the great thing about this is there's just so little configuration that actually needs to be done to have NAT working properly. So just to show you what we have set up, I'm going to go ahead and just do a quick show. Let's get into the interface here and do a quick show interface. Now I can just do tab complete to finish this. And what you'll see is I've got three interfaces set up. I've got a inside interface, an outside interface, and a loopback interface. The two that we're going to be mainly concerned about here is the inside and the outside interface. Now what I want is the inside interface is now all of these have private IP addresses, as you'll probably notice, but what we want is my inside labeled IP address. I want to be translated to my outside IP address if I need to go out to the internet. So this is actually incredibly simple to set up. So the first thing we want to do with the VYOS router is we want to go into configuration mode. So we're just going to type conf, and we can hit enter, or we can tab complete to do configure. And that's going to put us in our configuration mode. Now to set up this NAT, it literally is 3 lines. So what we need to do is create a rule and assign our interfaces and IP addresses to it. So we're going to start with a set NAT source rule 100, and this is going to be our rule 100, and it's going to contain all of the rules that we want. Outbound, and we can tab complete that interface. And I want my outbound interface to be ETH01 because that is my, as you can see, outside interface here. And just hit enter on that guy, and he accepted it. So now what I want to do is I want to tell the VYOS router which networks I want this rule to apply to. So we're going to do a set NAT source rule 100 source address 192.168.6.0, and we're going to do /24 because that's the subnet that we have here. We have a /24 subnet. And let's actually make sure we put this in quotes just to be safe. And there we go. And the last rule we have to create here is a masquerade rule, which is actually what's telling it to do basically the PAT translation, the port address translation. So we're going to do set NAT source rule 100 translation address Masquerade. Boom, enter. And that is it. Now once we do this, unlike Cisco routers where we type a command, it's not actually committed yet until we type commit. Now that we've typed commit, the settings have been saved or have actually been committed to the running config of the router. And now we need to configure them to the startup config of the router. So we're just going to do save. It saved our config and we are done. And that is how you're going to create the NAT address translation within the VYOS router. So in this video we took a look at what NAT is and why it was developed and why it was needed because of the lack of IPv4 addresses. We also looked at how to configure NAT within the VYOS virtual router on our system. So I hope this video has been informative for you. I hope you enjoyed it. If you did, please leave me a like. It lets me know kind of what videos you like to see, and it helps me know if you want me to continue on with these VYOS videos. So please leave a like and feel free to subscribe and check out some of my other videos. Thanks and have a great day.